audio and visual podcast, a weekly discussion about all things guitar building and some random tangents as well, featuring members of the Guitar Builders Collective from all around the world. The Guitar Builders Collective is a like-minded group of individuals that have come together to share their experiences, knowledge and inspiration for guitar building. Each week you can join us in the live YouTube chat or catch up at a later point. It's also available as audio, where you'll miss out on seeing our lovely faces and some of the visuals we share along the way. You can also find the Guitar Builders Collective via our forum, over on Instagram, where we share images of members' builds. We've got a thriving Facebook group, and we do hope that no matter what your experience and knowledge is, you'll become a welcome member of this community too. Fantastic. Hello, people. Good morning.
Hello.
Morning.
Good evening.
Good evening.
Oh, evening. Yeah, we're all in different places. We'll talk about that in one moment. Today is a slightly different episode to our normal kind of ones where we have a guest on and we talk about guitar building with them. This is our second in a series where we've got a theme that we're really going to focus in on. So today I'm joined by 5 people with a variety of experience in 3D printing, and we're going to really talk about 3D printing and guitar printing, but I'll get into more about what we're going to in a moment. I thought it'd be best to just introduce everyone first. And what I'm going to ask is if everyone can just very briefly say who they are, what they do, maybe where they are, but also what your experience of 3D printing is, just so we can give an overview of who's here for everyone watching before I talk about what we're going to actually do. So I'm just going to go round in the circle as it is on the screen, clockwise. So Jack, that means starting with you, if that's all right.
Okay.
Hello.
I'm Jack. I am Jason. I'm based in the southeast of England, in Kent, and my experience with 3D printing is mainly through starting with in lockdown. I quite liked I 3D model all my guitars, and I bought a 3D printer as a way of just checking my modeling skills, basically. So draw it and make it, print it, and started using it for jigs and things like that, and end product bits for guitars. So that's kind of it. I really like 3D printing. Bit of a nerd.
Fantastic. And then next to you, we've got Owen, who was on last week. Welcome back, Owen.
Thanks, Daniel. So I'm Owen. I'm down the south of Ireland in a place called Cork. I make guitars. I'm saying plural because I'm just about to start my second one. And my experience of 3D printing, I would have been an early adopter with some of the very first machines that kind of turned up on Kickstarter that were terrible and took like 3 years to set up. And you might get one print out of it if you were lucky. But these days I've got 2 3D printers in the house. I've got a standard filament-based printer and I have a resin-based printer as well. And I use 3D printing to make jigs and tools and stuff like that rather than the guitars themselves. And what I found is a lot of the 3D printing skills transfer over to laser cutters as well for making templates. So I've just picked up a laser cutter to stick onto the 3D printers and see what we can put together.
Fantastic. If we carry around in our circle, joining us at 3 a.m. his time is Mark. Mark, welcome.
Hey guys, Mark. I am a guitar builder in Austin, Texas, and I am a beginner 3D printing enthusiast, I suppose. So I just got my 3D printer a couple of months ago, and I'm just kind of diving into it.
Fantastic. Then in our middle here, joining us from Australia, Ray.
Hi, I'm Ray. I use 3D printing for guitars in that I use it to make tools and jigs, but predominantly guitars. All of the guitars you see behind me here are all 3D printed. On top of that, I actually work professionally in the additive manufacturing industry, which is another way of saying 3D printing.
Fantastic. And then almost finally, just below me here, we've got Glyn. Welcome.
Hi, I'm a pickup maker in New Zealand, and I got a printer about a year ago, and I've made a lot of mainly jigs. I thought I got one almost by mistake and thought, oh, I might have a use for it, and I run it. It's pretty much every day. I think if you've got one use for it, you've got 150 uses. So, but I'm really keen to learn a lot. I have never really deeply got into how to operate them. I mean, I design stuff and I make it, but I'm really keen to hear what other people have to say.
Excellent. I'm going to mirror Glyn. I haven't had my printer very long, but like Glyn, I've been using it every day. So if in case you don't know me, I'm Daniel. I'm based in Brighton in England, and I've just printed a 3D guitar here. I printed a guitar, not all guitars are 3D once they're made, but I printed a guitar using one of Ray's designs that he sent me, which we'll talk about in a minute. I'm assuming that most people watching this are going to have some experience of 3D printers and that understanding of the basics of 3D printing. But if you don't, that's absolutely fine. In the description to this video or the podcast, if you're listening on the audio, I've put a playlist up of past episodes of the Guitar Builders Collective where we've talked about 3D printing. So that really started with Ben from Battle Plan Harmonica Accessories. So not making guitars, but he makes specifically clips for harmonicas, but also now him and myself are collaborating making mic clips that kind of look like skulls and things. But anyway, he had a whole episode where he talked about basic CAD, basic designing, and the very basics of 3D printing. We've also had Jack on before, where Jack didn't necessarily talk much about 3D printing. We touched on it. He talked about a lot of CNCing, but also CAD as well. So if you want a bit of that, that's there. Ray, as you've heard, a bit of an expert and now a regular on the podcast. We've had 2 episodes with him specifically about his kind of career and introduction into 3D printing, into guitar making, and one about his experiments with different types of filaments, which we called the 3D printing tone wood debate or tone plastic debate. So go and check those out. There's some others there, including I did a live stream last night putting this together because I am a beginner. And putting it together really helped me understand a lot about what is integral for someone who's designing a 3D guitar and how we print it, because now I sort of understand what might be needed, but I'm still a beginner. So I'm here to ask some dumb questions of the people that know a lot. But I am hoping we get quite technical, because I'm sure there's some people watching this who have come either from the 3D printing world who haven't made guitars and want to learn a bit more about how you can transfer your skills to the guitars, or who have printed multiple guitars before and just want to learn a bit more. So that's linked below, as is links to everybody's social accounts, websites, etc., etc. We're not going to talk too much about actual CAD, about the actual design programs today. That's a whole other episode, but obviously we can talk a bit about designs. What I thought might be interesting just before we get into proper topics is just to find out what sorts of printers and what sort of technology and software people are using, so we've got kind of baseline of where we are all at. I don't know if anyone wants to kick us off, but I'll just let you know that I recently bought, on Ray's advice, a Bamboo Lab P1S printer with an AMS feed on it, which I found incredible, because as someone that hasn't done anything before, it's just been literally press a button and it prints. I got Ray's designs. They didn't have print profiles, although he gave me some advice on that, which we'll talk about later. But all I still had to do was drop your files in and press a button and it printed them. It was fantastic. Owen, you said you started off with those early Kickstarter ones, but what sort of things are you running now?
So the first printer I had was an M3D, and it was designed to be this really tiny desktop printer that even had the spool in the base, and it could print something like 100 millimeters cubed. But they made it so cheaply, and like all of the lead screws were plastic and things like that, and the hot end wasn't stable, so you couldn't get anything solid out of it. And really, the early days of 3D printing was a lot of that, and it was only until companies came along, like the one beginning with E-Ray, who are they? I'm having a brain fart at the moment. There was one of the 3D printer manufacturers came along and just really standardized everything in terms of using solid lead screws and solid frames, extrusions for the L-frames as well. And then that kickstarted the industry to better 3D printers. So what I have now is what I would consider a better 3D printer. It's an Artillery X1 Pro. I bought it because it's big enough to print a full-size Mandalorian helmet. It does 300 by 300 by 400, which sounds brilliant, except for the fact that when prints get that big, they become terrifying, because you're 20, 30, 60 hours into a print, and at the last minute, something goes horrifically wrong. So it seemed like a great idea at the time, but I think, a slightly smaller printer that's better, where you can assemble parts together, is a better solution for printing big things. That printer is a pain in the ass, by the way. So it's not as good as yours, Daniel, because you're in what I call the next gen of 3D printers with the Bamboo Lab stuff, where it does an awful lot of the calibration and measuring and testing and print, setting up the printer for the right filament correctly. My one does none of that. I have to get a sheet of A4 paper, like a caveman, and I have to slide it under the hot end and adjust each corner of the bed individually until it's just dragging. And then I have to set up the right temperature for the filament. And all of it basically is an awful experience. It prints beautifully. I've printed some great things. This is a vise that I printed that I use to hold pots and things when I'm soldering. And it came out really well, but the machine is just a pain to use. The other one I have is a resin printer. So it's a Wanhao Replicator 7. And if you're not familiar with how resin printers work, there's basically a vat of resin, and there's a light underneath that with a transparent bottom of the vat, and it pulls up the print a fraction of a millimeter each time, and the light cures that bit of the print and then pulls it up and cures the next print. So it's like 3D printing in reverse. It's kind of like the T-1000 in Terminator 2. You just fall out of this puddle, and then you need to cure it afterwards. And that gives beautiful quality prints. Like, they look like they were sometimes injection molded versus 3D printed. But they're the ones I have now, but I'm waiting. Bamboo are apparently releasing a new version of the X1 Carbon early next year. They're talking about it being a slightly bigger volume and things like that. And I think the second that's out, I'll be pulling the trigger on it, because I love 3D printing. But like the conversation we had about my workshop earlier, where if I want to go and do some woodworking, I have to pull out the car and pull out the motorbike and pull out the bench and set up the dust extractor, and it prevents me from doing it. My 3D printer is the same. There's so much work involved in getting the print going. It tends to put me off if I have to go and set up the machine and get it in place. So Bamboo for the win for sure for next gen printers. I'm a little bit envious of you guys with your awesome printers.
I've got to say, I was put off as a beginner with the whole concept of having to set things up and sort out calibrations, but don't have to worry about that now. We're definitely going to come back, Owen, to that idea of if the size matters, because it's something that I was thinking about a lot last night when I was assembling this. Has anyone else got a different printer that they use or software that they like?
Yeah, I mean, I've got a cheap one. It's an Anycubic Cobra, I think. But I didn't choose it. I mean, I just phoned a mate up to say, hey, cheap 3D printers actually work? And he goes, oh, look, I'll just send you one. Hey, I've got one. I've got a spare. So he did. I said, oh, do you want some pickups? He goes, yeah, okay. So we did a swap, and then a week later this thing arrived with barely any use for it, although that's changed. Interesting. One thing I'd like to point out that from a beginner's perspective is I didn't know what seems very obvious now. I didn't know what you had to do to print out a design. And I didn't realize that there was a thing between your CAD program and the actual printer. And when I found out, that felt really, really intimidating, having to do a sort of slice up program thing. And it felt, quite intimidating. And I watched quite a few YouTubes, and people love to use long words and make themselves sound impressive on YouTube. And it made it even more intimidating, but it's actually a total walk in the park.
Well, that's a great point, because I'm hoping we're going to hone in a bit on slicers and the programs we use. And if we're using intimidating words, I'm here as the dumb person to try and understand what those intimidating words are. But yeah, it's the same thing. I have only printed files that already had all the slicing files set up through Bamboo Lab, and two other things. Something that I got from Mark, a fret organizer. I had to put that in the slicer myself. Didn't know what I was doing. I pressed a button and it did it for me. And the same with Ray's. But I realized from what I was discussing yesterday with Ray when I was putting this together, I printed this potentially at not necessarily the best settings, potentially the wrong settings, and the guitar might not work. But we'll get onto that in a moment. I just want to find out, first of all, if anyone else has got a particular printer that they're using, again, that maybe is different. I know, Ray, Ray just posted on Instagram, links to his Instagram below, a guitar that he's recently made that a company have retweeted because you printed it on a massive printer, so bigger than the one Owen was talking about. Could you tell us about that?
Yeah, certainly. So as I mentioned a few minutes ago, I work in the additive manufacturing industry. So I work with all sorts of printers. So FDM, your filament printers, your resin printers, MSLA, and teeth back in, start again. Also work with SLS printers, which we can talk about a bit later on. But one of the ones or areas that I do a lot of work in is large format printing, which is basically printing big stuff. I do a lot of stuff with printing like car interiors, car dashboards, and obviously, and also actually there's one of my long-time customers prints, he designs bells for like church bells and things like that. And he has me basically print a model in plastic so he can then make a stand cast of it. And he sets my model on fire to burn it out of the cast. But working with the large format printers is great. It's a lot of fun. You have a whole different mentality when you approach printing something on one of these printers versus like a smaller desktop machine. Like you're talking, about when you mentioned using the artillery sidewinder, you got a print going for 20 hours, 30 hours. Some of the prints that I have, like there's an amplifier and a guitar sitting inside the printer.
Yeah, I'm just sharing that post on the screen now for anyone that's listening.
So my longest print so far on one of those machines has been 6.5 weeks. It's non-stop, continuous printing. So that anxiety that you feel, Owen, when that thing's going for 20 hours, 30 hours, I have a lot of sleepless nights. Because what Owen was saying was, like this print can fail at any point in time, and there is, at the end of the day, that big red printer that you see there uses the exact same software as this printer does. It uses the same language. It really is just an overgrown one of these. Actually, no, I'm sorry, it's not an overgrown one of these. That would be amazing if it was. It's an overgrown M3D printer that you used to have. It uses the same language, prints at the same speed. It just prints big.
Oh, so can I just dive in there as a novice? Are you saying that these, Owen was mentioning that Bamboo Lab that you recommended I got is kind of the new generation of printers. Are you saying then that the big industrial scale printers you're using maybe don't have such innovative technology or hardware in them as the smaller new printers?
No, they don't. They really don't. I just finished assembling a printer today. I did my first test print on it. This printer retails for about $45,000 US. And I leveled it with a piece of paper.
Amazing.
To me, it's ridiculous, that I'm still doing this. But on the same hand, there's a reason for it. When you're dealing with printers like this and your print goes for 6.5 weeks, that print must finish. It has to finish. You can't get to, end of week 5, start of week 6 and have a topple over. It's not just a case of how much money have you lost in filament because you've just dumped 40 kilos of filament on the ground. It's how many man hours of labour have you lost? How far did it set the project back? So, because it's working for a business. It's printing to make money. so oftentimes they actually have to strip a lot of these fancy things back, and we go back to your bare bones basics. So things like self-leveling or auto-leveling beds, they're only just starting to come into some of these large format printers in recent days. And as for printing like a bamboo does, that's going to be a long way away, I reckon. I really do think that. Certainly printing at bamboo speeds is years away. Biggest reason I say that is on a bamboo, your extruder or your tool head, so to speak, weighs about, I think it's about 150 grams, maybe a bit more. On the big rep, it was 3.5 kilos that is getting slung around. So
when you say it like that, it seems obvious that the technology has to be quite different because of the size and weights of things.
Yeah. So I was saying, like, you approach it with a different mindset. Like when I print on this thing, I try to remove as much support material as possible. I'll change the angle so I have less support to remove. Whereas when I'm printing on a big rep, I start adding support material in. And it'll extend the time out because it's got extra work to do, but I'm guaranteeing that my part is going to finish. So if that means that I'm going to use an extra 3 kilos and add 3 days on to a 6-week print, but I get the print and I get some more sleep during the week, then I'm going to do it.
So I guess what's coming to mind here for me then is this idea that 3D printing isn't necessarily going to be something big companies are doing for mass-produced guitars because of the complication of it all, potentially. But it's something that's going to become much more common for people just to print at home as high-quality printers become more affordable and more ubiquitous, I guess.
Yeah, I think if you're going to scale it, you're not going to 3D print. You're going to injection mold.
Yeah. So one thing I want us then to talk about today is for the person that's printing at home. And one thing that really became apparent yesterday when I was assembling the print that Ray sent me is the way Ray makes them, and we'll look at this in a moment, is very much it's a jigsaw piece that fits together. We fit together the back of the guitar, you fit together the front of the guitar on top of the back, so they're kind of attached together. You can see the jigsaw piece. Look, Glyn's holding one up. Fantastic. Glyn, we'll ask you about your experience in a moment of this. This seems to be one way of assembling the guitars. But if I just do another screen share, if you don't mind me showing this, Mark. Oh, no, wrong screen. Mark, for example, this is one of your 3D printed ones, Mark. You've made it in a totally different way, but the way it assembles kind of hides all of the join. I know Ray does that with some of his designs as well. But I wondered, maybe, Mark, you could talk us through your thought process of how you design a guitar with the printer in mind. Because obviously, Ray just had that one printer that prints really big, but we've got smaller scale printers. We have to print in parts. How do you approach that printing in part or designing to print in parts idea?
Yeah, I think I even talked to Ray about this. I was like, I need something bigger. I need a printer that can print the whole thing at once. And that's what I was going for. The whole reason I got into 3D printing was because of my designs, because I was designing things that could not be made on a CNC. They just couldn't. So I reached out to some 3D printer manufacturers and I asked them if they just send me a 3D printer for free. And they did. And I give them the video, in exchange. But for me, it was all about, again, trying to find the maximum solution, like Ray mentioned, to position onto the bed to get the biggest piece possible. And I was kind of working backwards from the design perspective and kind of trying to cut things up in the design space to accommodate the bed, but also trying to hide the seams. So the jigsaw method, I think, is the best method. I don't think you can beat that method. My method was just basically gluing things together in order to, I guess it's basically form over function, just trying to hide the seams. And I basically compensated with using carbon graphite rods. So I have carbon graphite rods, 4 of them, in like a stacked manner. So there's 2 on top and 2 on the bottom, and then the whole guitar just kind of like fits in with little tabs. So I've designed in sockets and like little tabs, and they just kind of stuck in like that. And that way, when you glue them together, they don't slide, they don't move. They're just basically stuck in there. And I used epoxy.
So are you saying that you designed the whole shape of the guitar and then went in to work out how to slice it up or cut it up to fit on the bed?
Yeah, exactly. So I've been designing a lot of guitars that can't be created on a CNC or in any other traditional manner. And this was one of those. And so once I had a design, once I had the 3D printer, then it was going through a second stage of design to say, how am I going to cut it up? And then after I cut it up, I had to design the tabs and then design the slots for the carbon fiber rods and basically everything else.
Interesting, because when I look at it, it looks like, because of the way it so seamlessly fits together, that you must have had in mind that bed idea, the size of the bed initially. But obviously it's just good design or good working out of of practical working out of how you can convert that design to fit them.
Yeah, but again, when I was in the cut up stage, in the design stage, I had my bed dimensions, and I would kind of rotate this like square and try to figure out where that square would fit. And then once I had it on the guitar, like for example, the pointy bit, right? I would kind of turn things around and then kind of draw a cut and then cut like that. So I was trying to maximize the pieces to be as big as possible, but then also trying to think in 3 dimensions, like, because obviously you can print up and down, like vertically, instead of just laying on a bed. And so I was thinking in terms of how can I maximize the space to get the biggest chunks possible.
So you designed the thing, and then you figured out how to make it.
Yes.
Yeah, I think that's a great approach, because it's the thing that's the important. The final thing is the important thing, not the method that you use, isn't it? No, I think that's great.
Yeah, because
I have to watch some of your videos now.
Yeah. Well, that video that I just briefly showed in the background has a lot of Mark zooming in on his designs and pulling things apart. So I'm sorry, I'll get on to Jack in a minute. I can see Jack's getting some bits ready. I just want to go back then how that compares, for example, Ray, to your approach with a specific question in mind. When you've got, for example, a guitar design that already exists, a shape that already exists. We had In Gold Audio on a couple of weeks ago. You've made one of his designs. When you're taking a design that exists, how do you decide how to break it up? Is it just simply I'll jigsaw it on pieces that are big enough to fit on the printer? Or are you taking into account something that the way you divide it up adds the strength to it, so you don't need those rods that Mark was talking about? So, for example, the amount of pieces means more internal walls. Does that make it stronger? Or am I just being a bit dumb here and you can make it big and do more infill?
No, you're pretty much spot on. So one of the things that I've worked out is that, like Mark, you were talking about how can you maximize the space and get like the biggest parts onto the printer. And a lot of the times I used to work in a very similar manner. How can I can rotate it a little bit, and I've now learned do not rotate my parts, because otherwise once it goes together you get a totally different finish across it. But what I have found when you boil it down is that the smaller parts, when you bring them all together, when you have multiple smaller parts, you actually end up with a far stronger body than printing in larger parts. So, for instance, the Orange Meteora is printed in one part, and I actually had to create inside my model. I had additional models of essentially just long blocks that were effectively solid plastic. So I almost basically added in bracing and supports in the model, purely and simply because the walls of each part is what actually provides the strength. So you'll notice, hang on. So the SG, as you mentioned earlier, Daniel, you have a front and a back. You can probably see the seam just in here. That's because the top of this guitar has a seam running right down the middle of it on the top. But then when you flip it over, you'll see that I've got two seams running either side of it. So I've essentially created three braces within there, just using the parts, the actual shape of the parts themselves. Additionally, on top of that, the jigsaw shape, the idea behind it is that if my part is 150 mil long, that's, and the guitar is 44.5, let's say 45 millimeters tall, you have a wall running down and you've got two mating surfaces that you're trying to bring together and glue together. That is 150 by 45 millimeters. That's it. That's all you've got. Any stress or tension or torque that is put on those two parts can only be spread across one angle, one axis on the part. When I drop in the jigsaw shape, I effectively, those stresses and tensions get spread at about 360 degrees at any given part. And on top of that, again, the overall surface area goes from about 150 mil out to about 250 mil. So the actual surface mating area is much larger. So yeah, that's the whole idea behind the actual jigsaw puzzle.
I just shared on screen one of the jigsaw designs, but also you've got this one, which is, I guess, an equivalent of a jigsaw. It's more like a camouflage pattern, but again, it's printed in parts.
Yep. So that one is actually taking the many walls make strength a little bit too far. So that body there probably, with all of those walls, I think it weighed about 3.8 kilograms by itself.
Right.
So that's heavier than most guitars.
So I want to get into weight and how that relates to the amount of filament we're using in a moment. But just to say quickly with this one, so people that aren't watching, it's a what's that design? It's a dime bag. What's the design?
Yeah, it's an ML shape.
An ML, that's it, yeah. It's an ML shape. It looks like it's got a camouflage effect, but in these kind of pinks and purple colours. But one thing that you've done on this and that blue and white guitar that I just showed that was a jigsaw put together is you're using the process of how it's made as part of the visual aesthetic. So the joins that you're getting from the jigsaw, the joins you're getting there from that camouflage shape, they are integral to what the guitar looks like. So you don't need to hide them. So that's cool. Because one thing I want to talk about is how we hide the joints, how we hide the way it's made.
Yeah.
Interesting though is what you've mentioned about the jigsaw isn't just a byproduct of how we print it and our needs to print it. It also adds to the strength of it all. Jack, I know, Jack, you make a lot of jigs and things, but you've also 3D printed some guitars. Did I see you grab something you wanted to show us?
I did. I was getting excited. You were talking about your guitars. So I did quite a few guitar shows, and the feedback I was getting was like my guitars were a bit heavy, which they're not. So I decided to go away and see how light can you actually make a guitar body. So I took one of my guitars, sliced it up essentially. This is like part one, as you can see. It was sliced up into bits, again with a central seam. And this was done purely for weight saving. So it was in PETG carbon fibre infused filament. And I did minimal walls and like I did like one wall and like 5% infill. So it's quite flimsy in a way. Yeah. I was going to people like, how could you get away with it? And it actually, it's 3/4 of a spool, so probably like 750 grams. There you go. Some bits I did solid, so where you got the string ferrule, that is a solid block, and through the bridge mounts. The rest of it there's nothing to it. And then after that, after I made the print, I then covered it in carbon fibre cloth with epoxy resin. So this is under a kilo still. And then I took it to a show and people said it was too light. It feels like a toy. So I went too far with it. It does feel quite light. So I think you can go too far without trying to. You can either go make it really heavy or too light. There's a magical mix somewhere in the middle. But even though it's very light, it's very strong, and you could probably play cricket with it or something.
Is some of that strength coming from the carbon? Jack, we're getting that feedback again.
Yeah, there's definitely a bit of that going on there. I wanted to hide the fact it was printed, just as a conversation point. That's kind of why I covered it up. But seeing all your guitars that were printed with the jigsaw pieces it looks good. It makes a lot of sense to spread that load through how the pieces fit together.
But that one obviously works. You've had it. Jack, if you can move your mic closer,
Again. Yeah, it does work. I think if I was to tackle it again, I would increase the walls and a bit more infill, and try not to make it so light next time.
I love that it's like Scotsman sometimes. Guitarists don't know anything. It's too heavy. It's too light. Really. So
yeah, along with the guitars I'm making, I also make lots of jigs and things like that. I think stuff around the workshop is you need a 3D printer for making drill jigs and even like hooks around the workshop. It's an indispensable tool now, I find.
I definitely want to come back a bit later to talking about the jigs and things we make. But we'll think about the guitars first. But it's interesting that you've done some of those bits more solid, because that's a question I just wanted to open up in a moment about how we know where things need to be more solid, like where the screws are going, for example. But I just wanted to quickly ask Glyn, because Glyn, you had your 3D printed jigsaw guitar there a moment ago. Is that one also one of Ray's designs?
Yeah, I know. Absolutely. It's actually the only thing I've ever printed that's from somebody else's design. So yeah, that's one of Ray's, and the photo he sent me beforehand had these same colors, and I thought, oh, that looks really cool. Oh, it's made of lots of bits. Why not just show that off? So we haven't put it together yet, unfortunately. I had meant to do that by now, but this time of year it just gets too hectic. But yeah, it's neat.
I can see something that's different on that one, which is it looks like the jigsaw bits are the thickness of the body, as opposed to the design that we were just talking about, where it's the top half and the bottom half. Yeah,
a lot of them are, but not all. Yeah, some of them around the top here are a front and the back. But yeah, a lot of them are the full, whatever it is, 45 mil. Whatever the imperial equivalent is, but yeah, it's pretty much it's obviously a Strat, and the weight wise, I'd go ash sort of weight, not the really 70s Fender heavy ash, but kind of medium ash weight. I haven't heard the sound of it, but it sounds like there'll be a lot of lows in there as well as the highs, because there's a lot of air ligging about inside them. But yeah, I need to get it together to.
I mean, I just sprung this one up very briefly. I haven't intonated or anything because I did it all last night. If anyone wants to see how I put it together, that's linked in the 3D plate. Oh, there, out of tune. But it is definitely feels like it's got a slight hollow body feel to it. But I'm going to come on to that as well. That might be because of how incorrectly I've printed it. So when we are talking about the weight, I printed this. So Ray very kindly suggested some settings for the printer, which I ignored for a reason. I wanted to get it done for today, and I realized if I printed it on the basic print setting on the Bamboo, so when you import a file in that hasn't got a print file settings all set up, you've got some very basic options you can pick between, and then Bamboo does all the rest. And the very basic one means that all the lines, all the layers are very visible. The very advanced one, the lines and layers are almost invisible, because obviously it's printing thinner layers, it's taking more time on it all. But this I printed very quickly. So I printed the top half in one day, I printed the bottom half in one day, and it wasn't even a whole day, it was just when I was getting on with things. And it meant I had it ready quickly. But as Ray is saying, that means all the walls, everything about it is thinner than the options that Ray suggests I use. So what I want to do is I put it together last night, and I've only just really tightened the strings a bit, because I don't want the strings to be too tight on it, because the plastic weld I used recommends leave everything 24 hours. So I don't want it to just like rip apart straight away from the string tension. But I'm going to end of today set this up properly, and then post Christmas come back to it and see if there's any give. Ray suggested that if you're printing it at the wrong settings, there could be a bit of give, and you'll start to see the body bend a bit, you know, the strings height raise. But I want to give that a test, because like we've just said, we've had all of those parts that are the jigsaws. Maybe there is enough strength to it, but I don't know. Ray, can you just talk us through what that all means, how you know how thick to print things, etc., etc.? Oh, and by the way, this isn't ABS, it's PLA. I want to get onto all of that in a moment. But Ray, what does the actual, when you're going in your slicer and setting it all up, what are the best settings for things like this? Or how do we know what they are?
Well, trial and error. So the reason I know that, you know, if you go too thin, you know, it'll start to fold up and you'll get some crazy high action is because it happened to me. I was trying to find basically the optimal settings where I don't have to use too much material and make a very heavy guitar. And I didn't want it to be too light. Like Jack, that guitar at under a kilo, the first thought that comes to my head with that is, love that idea, but like an SG. It's, you know, so the other reason that I tried so many different settings is a little bit of the old tone wood debate. So I don't call it tone plastic. I refer to it as tone polymer. Thank you. Just to be clear.
Sorry, tone polymer.
But the vast majority of changes that come with the guitar's sound and the wood is like we can talk about the way the grain is and all of that, but the biggest factor in there is the density of the material. At the end of the day, it's how heavy it is. Higher frequencies, you know, carry a lot less energy and they won't travel as far. So the denser the material, they'll travel even less. Anyway, what I wanted to do was, and I've been able to do this now, is I wanted to be able to vary the weight of the guitar and have the exact same guitar. So I wanted to be able to make a guitar that, you know, has sustained for days and has a big bottom end, and I found that, yeah, I can do that at the cost of at my higher frequencies, just like using a really dense, heavy hardwood. I've got that little bit of control. I'm not going to go into the tone wood debate too much. One of the things that I found is basically 5 millimeters thick. I used to see people adding like carbon rods and things like that, and they used to like using like a 5 and a 6 mil carbon rod. So I thought, well, if I can get my walls, which are, you know, the entire height or thickness of the guitar, to be close to that, there's going to be the ultimate thickness. So given that each part will have its own wall, I wanted 5 mil. You've got to work in multiples of your nozzle diameter on the printer, which are, for most people is 0.4. For myself, I'll use anywhere from a 0.6 up to a 2 mil nozzle. But most of the work on these bamboos I'm doing with a 0.6, 2.4 millimeters. That's where I found the sweet spot to be, is 2.4 millimeters on my walls, on my top, and my bottom. Then of course I play around with the infill pattern and how much percentage there is, and you've got a lot of leeway in what you can do with that. The biggest thing is that you want those walls, when they're combined, to be or when they're combined, you want them to be 4.8 or 2.4 on each part at a minimum. And I've also kind of found that seems to be the sweet spot. In the instance of like the Meteora, where you've got a front and a back, the two surfaces that make together on that, I tend to thin those out a little bit. And I'll actually come down to about 1.8 on the top and 1.8 on the bottom. The reason I'm okay doing that is because we're gluing the entire, shape of the guitar together. So we've got a lot of surface area there. Once those two parts are locked in, keeping in mind that the glue that I use is not so much a glue as it welds the plastic together. So it's essentially creating one single block, not two parts glued together. It's creating one block.
Yeah,
for the most part.
I think we want to talk about the welding in a minute. Sorry, can I just interrupt in case people haven't seen the photos or I haven't explained properly? When you've got your top and your bottom, the jigsaw parts don't correspond. It's not an exact copy, so that the walls overlap. So it's got that extra strength. It's not that the top jigsaw parts are exactly the same divided as the bottom. So when you put it together, you've got that extra strength there, which seemed quite important. Maybe anyone else can chip in here, because as Ray's talking, I've got questions going around my head. The way you're having your thinner walls between the top and the bottom, it seems to me like if I look at a guitar, maybe you only need the thicker walls to be in the core part that goes along the middle, where you don't want it to walk, where all the tension's put, and the walls could be thin around the edges for the weight relief. But then Mark's put his rods in, Jack's got his carbon fiber wrap, because one thing that surprised me, again, I potentially printed it at the wrong setting, really thin, is how light this is. I know you're talking about the problem of it being light, being the necktie. I found it interesting what Glyn was saying about it feels like ash, his one. Maybe that weight, like you're saying, Ray, having the same design but different weights does make that difference. But I just wonder what anyone else thought about how to keep the strength up. Or
well, I actually listened. I listened to Uncle Ray, and I abided by all his advice and settings. You see, and
Same here.
I mean, this. Yeah. I've no doubt that this thing is strong enough for anything it's going to get. So yeah, no, it feels very robust. And I think the ash thing. Sorry.
Oh, sorry. Go ahead. I was just saying I also followed all of Ray's advice with thicknesses, wall thicknesses, everything. Like just everything he said, I did, and it came out perfect. You can't go wrong. But now I'm fascinated by the carbon fiber enclosed 3D print that Jack did. I'm just fascinated by this because I keep thinking about the way that normal traditional guitar makers make guitars. And we always think about a very dense hardwood core, yet we have untraditional guitar builders like Ken Parker who use softwood as their core, and they enclosed it in an exoskeleton, sort of like a lobster, right? And it works the same way. You have the same strength with a softwood core, and then you enclose it in some kind of like a rigid exoskeleton. So Jack, I want to hear more about this guitar. Truly, like, did you string it up? Did you play it? Does it work?
Okay. So yeah, it was strung up and it was working. I took it apart, so I wanted to redo it. It had a wooden neck. The fingerboard was Richlight or paper stone. I don't know if you know what that material is. Paper laminate resin. So it's lots of recycled. I wanted to do sort of new materials rather than just wood. But yeah, it played nicely. It had quite a nice acoustic tone to it actually, because it was very hollow. And it did. I mean, because it was so light, I think going back to it, you could have put spaces in the print somewhere for like weighted blocks to help with neck dive. You could put them in halfway through the print. You could put like a block of metal or something, something with a bit of density to it. You can put that in there. And I think I used the PETG carbon fiber reinforced PLA filament, which is quite nice. You quite use them sort of engineering filaments. Starting to play around with the carbon fiber nylon, which is quite fun to use. And the Bamboo Lab X1 is what I got. It's very good with those sort of engineering filaments. So yeah, I think having the shell on the guitar really helped with its strength. I did go a little bit light with the walls. I saw Ray's eyes. Oh my God, at one word.
I was going to say, you've had that guitar a while. I saw it over a year ago, so it definitely has worked, despite the fact it had the thinner walls. Can you just explain, though, in case some people like me don't quite understand, when you say encased it in carbon fiber, what does that actually mean? How do you do that?
So it's a cold lay. So epoxy. So you put like a black epoxy, let it go tacky, and then you cut your fabric and you lay it on so it sticks. And you do that both sides, and then you put layers of epoxy over the top, about 3 or 4, and then sand and polish. That's a bit fiddly. That's basically it. And then you get a very hard lobster-like shell, like Mark said, and it definitely did the job. But the feedback I got was it was just too light, which wasn't what I was expecting really. So yeah, going back, you could do it with thicker walls, and I think it would probably print quicker. Or you could put little blocks inside to help distribute with weight.
So too light is music to my ears. Like when I hear those words, like too light, that's what I want to hear. So I'm fascinated by this idea, and I definitely want to try it.
You see, Mark, when you said Mark about guitars having a harder core with softer stuff on the outside, but think of an ES335. That's got an exoskeleton with soft stuff in the middle. It's got air in the middle, mainly. So it does work, and an ES335, like the ply, that ply they use, is actually pretty strong. So
I think that's why I was wondering if the core was just the thicker walls, whether the outside could be more open. And also, look, there's so much to think about here. What Jack was saying as well about it being too light. What a selling point for your guitar. The guitar's so light, you could add weights to it. Like you could have a bit in it that you could add your weights to. It could be the perfect weight for you.
But no matter how light the body, if you can get that top strap hook roughly over 12th fret, you're not going to get neck dive. I mean, the SG issue is not the light body; it's where that strap hook is located. It's not a weight issue.
Yeah.
I think being so thin doesn't help it either.
Sorry.
I think SG being so thin doesn't help it either. But predominantly, it is a balance act.
Yeah, but if you could get that strap hook over 12th fret, if you could move that up, I mean, obviously you can't because there's nothing there. But then really, if you take, I remember years ago doing a job for someone on a what they call Steinbergs, and we had a rod. We made I think it was aluminium, or it might have been steel. No, it must have been steel. A steel rod that was probably about 10 mil diameter, that came out the top of it and went curved over and ended up roughly over 12th fret, and the whole thing. I mean, I know it hasn't got a head, but the whole thing felt so different and much more natural to balance. Pretty much anything will balance if you can get that strap hook far enough. But unfortunately, that you end up with a huge top horn sometimes, and we all know what that looks like.
I hope there's someone watching that, like Mark, has just been inspired to try some music to their ears. I hope there's some people that are thinking about all this, thinking, oh, with my next print or my next design, I'm going to make these changes and try things out. Let us know in the comments what about this is useful, that's inspiring you to try something, or that you've done that's different, or just share with us, like the Guitar Builders Collective. I didn't really talk about this much before, but we exist as a group of people on Facebook, on Instagram, and there's a forum as well. There's links in the description. Go and share with us there, because we always like to see new builds, see what's going on.
You know what? Sorry, what you know what I feel this, not only the weight, but I think the consistency of this feels very much like ash to me. Because if you take a piece of ash, you've got very hard growth and you've got very light growth. If you try and sand ash without a sanding block, it ripples. It looks like the tide's gone out. Because you've got the very, very, very fast spring growth. It shoots first to shoot up in the spring, and then it grows some really hard wood. And so ash, you get two resonant frequencies for the price of one. You got the hard stuff and the light stuff. And I see this being the same thing, because the PLA is pretty hard, and I can hear a high frequency in it, but there's lots and lots of air, and so that's my instinct, is what this is gonna be like.
I think you're gonna like it, mate. I think you're gonna like it.
I've been making some videos of the making of. Yeah, my 10-year-old daughter is very keen on this, and so she just slowed us down, because she's going to be part of making it. So
awesome! I love that.
Yeah,
I love that. The actual Hello Kitty guitar I made is actually being donated to a little girl as well. It's going to my pedal builder's daughter. But Daniel, I wanted to go back to what you were saying. You were talking about printing the core heavier and on the outside lighter. So when I said to you that I'm happy to set up the print files for you, that's exactly what I was going to do. So if we take this this telly that I'm doing for a YouTuber, a left-handed Telecaster, if that gives you any hints.
Australian?
This rolling, pardon?
Australian?
Yes.
Oh, okay.
So this row in here, except for these two parts, but everything else upwards. So the core, basically everything in between pocket and the bridge. All of the walls are 2.4 millimeters thick. The infill is 25% and using the gyroid shape, which uses a lot more filament, a lot more time, and creates a crazy network inside. However, all of the parts on let me flip it around. All of these parts around the outside edge runs 1.8 millimeters and has either 10 or 15% infill ratio. And I do that a couple of reasons. Given, like we were talking about the SG, if the strap pin was over the 12th, you'd be better off. I can make a guitar tail heavy. I can make it want to go down at the back, or I can make it want to go neck dive, all depending upon what you want to do. So when I did that blue one, that SG with the Bixby, because I got the Bixby on there, I did actually do a little bit of that, and I crazily, as a lot of people I would shifted some of the weight towards horns. But it allows me to just shift that weight around.
I'm so intrigued, and I know there's a whole debate about tone polymers.
Yeah.
But I just do wonder if changing all this can change the sound. I doubt it, but just put that out there, so people can join in the chat. And talking about joining the chat, there's some questions that I want to get back to in a moment. Harmonicast has asked a great question. I want to talk about how we actually assemble it, the welds and the acetone, blah blah blah. And Jack mentioned filament choices in a minute, but Owen, I just want to quickly ask you. Maybe you can answer this. Being that you have a resin printer, is a resin printer at all suitable for doing any of this?
Not at scale. Resin printers tend to be quite small. So if you were even to consider doing something like this, you would be printing many parts and having to put them together. So I don't think it's I can see Ray's eyebrows just jumping up and down there. I think it would be a path of misery and depression, so I wouldn't recommend it to anybody just because of the amount of work involved. And the advantages you get with the resin printer in terms of the print quality would be diminished by the fact that you have to put all of those pieces together.
And can you get resin? Can you get resin in different colors?
Yeah.
Okay. Because that might, if ever I were to make, I've never made a pick. Well, I've tried printing pickup bobbins, but it's just not smooth enough, you know. So resin might work for that.
Yeah, I think resin comes with its caveats. When you're talking about FDM printers, like filament printers, there's inherent ways to build in strength into those. And I think with the resin, it's kind of a lithography-based printing solution. I would have concerns about the comparative strength of resin versus FDM. Ray can probably talk more about that than me. But yeah, I think you definitely up the quality for sure. But I'm just wondering, is the juice worth the squeeze?
And what about temperature? Because if I were wax potting something, it's at about 70 degrees centigrade. I wonder if it would get a bit wobbly.
I think it would be okay. It depends on the resin you use, because there are different resins as well. There's like water washable resins, and there's other ones that need to be cleaned with solvents. So I would look at the specific. There's usually spec sheets for the resins anyway. I mean, I have a bottle of where is it? This is just Amazon water washable photopolymer resin here. It doesn't mention anything about. Yeah, recommended temperature for printing is 20 to 25, but it doesn't talk about anything in terms of what it can take temperature-wise for working.
Is it brittle?
They tend to be, yeah. So the most frustrating thing with a resin print is that when it's printed, you're not finished. You then need to take it and treat it. So it's a really good question mark actually, because I got the printer. I was like, yes, I have a resin printer, and then I realized, shit, I have to go and get something else. So I had to buy this pure station where you have to transfer your print in, and it bathes it in this mist depending on what resin you've used. So if you're using a water-based one like this, you can generally just cure it. It goes around with a UV light shining on a little turntable. And if it's the other type of resin that needs to be cured with solvent, it literally sprays a mist while it's spinning around inside in that tank as well. And that mist is good. That mist can reduce imperfections on the surface of the print sometimes as well. In fact, when 3D printers were really bad, if I think back to my first 3D printer, that M3D that printed in PLA, people were selling machines and special filaments so that you could put them into a misting solvent bath that would make the outside of the print smooth and glossy as well. So it's a very different process. I've used it for honestly, I made a chess set at one point for somebody, and it turned out really nice because they were miniatures with high detail. But I'm just not certain of the scalability of this towards these jobs. I think if you're making hardware for guitars, like knobs and things, and you're probably thinking along this path, Glyn, for pickups and stuff like that, I think that could work well. But I'm just not sure of the viability of this stuff for the actual body of a guitar.
Interesting. Hey, look, I definitely want to talk about that. Making
that.
Sorry, Ray.
Sorry, just wanted to go like so. I'm trying to make I've done this, I've done that, but because I work in the additive manufacturing, I have done a lot. So I have actually printed a body in resin. If you wanted to play that guitar, first off, you would need a chiropractor's appointment, because of the sheer density of resin. I mean, that stuff is thick and it's heavy, and unlike FDM printing, where you've got your percentage of infill, it's 100% solid. So that ends up being a very, very heavy guitar. I've also done it in SLS, which is basically using a laser to melt powder. Same deal. It's 100% solid and becomes extremely heavy. But where things can change is just like in FDM world, we have engineering type resins. So we've got flame-proof resins. We have the first thing that's popping to mind is about a dozen different biomedical and dental resins that are totally irrelevant here. But one of them, which can be of a lot of use in guitars, is what this one here is. So it looks like just typical white resin, except it's actually 35% ceramic. So it is extremely brittle. You don't want to drop it. However, it's also extremely thick. So this was essentially just a trial baby grand bridge that I was trialing. But because it's so dense and you can get the, what am I trying to say? You can get the strength out of it. You can do things like I no longer make file or sand a guitar nut. I simply design it and I print it in this material. Given that density, it is perfect. It's denser than bone. So it's just some food for thought.
On that note, can I go just back to Jack? Because Jack, you were mentioning some other filaments that you've been using or have available. Can you just explain a bit about what they were and why you were using them?
So I've been using the sort of carbon fibre infused filaments purely for strength. I think you can even get glass fibre infused filaments now, which is it's not like a single strand. You can get printers to do that. It's chopped carbon fibre, which is put in with when they make the filament. So you have to use a hardened nozzle. All the manufacturers they tell you what you should be using, whether it should be a 0.6 or a 0.4 or that, and where it should be a hardened nozzle, because it should be hardened, because if it's not, then the carbon fibre as it goes through the extruder will make your 0.4 nozzle of 0.6 quite quickly. It's abrasive, and then you'll get bad prints, which is what you don't want really.
You're muted, Daniel.
Well, I've been muting myself. Your mic, Jack. I don't know if you can. Thanks. Yeah, I just wondered. So obviously the carbon fibre gives the strength. The ceramic infused gives that sort of strength. What is PLA fine for the basic guitar prints? Should we be using other things? Harmonicaster mentioned in the live chat here that he's used ABS as well. He enjoys using ABS. I don't really know enough about the differences to know which ones has the best properties for what we're doing, if there is a best property.
So I primarily
So go ahead, Ray.
Yeah, sorry, didn't mean to jump in there. The vast majority of these guitars here are ABS. And the biggest reason that I use the ABS is not because of strength, because the reality is PLA is extremely strong. A lot of people don't give PLA enough credit for just how strong it actually is. But the biggest reason I use it is actually the density. So we measure density in, how many grams does something weigh per cubic centimeter. When we look at a softwood or a light hardwood, like we use on a guitar, the density is somewhere between usually about 0.4 to 0.8 grams per cubic centimeter. And ABS and PLA are actually much heavier. But PLA is often, depending upon the type, is 1.4 to 1.5 grams per cubic centimeter, and ABS drops down to about 1.1. So given the amount of material that we typically use in a 3D printed guitar, especially when you have a lot of parts, so like the yellow and orange Telecaster, that has a lot of parts in it. That's a lot of walls. So if I'm not careful and I'm using PLA for all of that, that'll become a very heavy guitar. In the instance of the Meteora, where we made bigger parts, we can move safely to PLA and not be concerned about the weight. So again, the biggest reason is more just the density. It's yes, PLA, will warp at a much lower temperature. You don't want to leave a 3D printed guitar in the car in summer. Hey, you don't really want to leave any guitar in the car in summer. It's just that the results can be a little bit more catastrophic with a printed PLA guitar.
Hey Ray, I have a question. Since you're in the additive manufacturing industry and you have quite a bit of knowledge on 3D printing, as guitar builders, most of us, can you talk a little bit about the health factor of some of these filaments? Maybe there's some kind of concerning factors over just warming up or heating plastics and health concerns.
Yeah. So it is definitely something that you need to be mindful of. So PLA is considered to be an extremely safe material. We refer to them as VOCs. Like any type of chemical has a VOC, basically the amount of noxious chemicals that are harmful to the human body in them. They say that PLA is absolutely safe and perfectly harmless. And look, you know what? They're probably right. We know that materials like ABS and ASA are not quite so safe. The S in both of those stands for styrene, and burning and melting styrene is just really bad to the lungs and the body, and it's just not good. So those materials, you don't really want to print them in the office. So I've got the printer here in the office. Typically, when I'm using those materials, which is most of the time, I'm actually not in here. The window right behind the printer is open, and the reality is that's probably not enough. I probably should be doing more. But I can be a little bit lazy. Now, what I did want to touch on is PLA. As I said, we typically regard PLA as a extremely safe plastic. I mean, it's not made from oil; it's vegetable based. It's based, it's made from corn oil, essentially. At the end of the day, and I know, they also say that it's biodegradable. Well, kind of is and kind of isn't. To break it down requires some really specific circumstances, and as a general rule, you don't find it naturally in the environment, so it's not going to break down. But it can be done. However, what I did want to touch on with the PLA, we say there's no VOCs, or that the level of VOCs are not harmful to us, and that the gases that are coming out off of it are not harmful to us. What I'd like to say is do we all remember asbestos? They said that wasn't harmful. Now, we do have a lot more, technology to determine what is safe and what isn't. However, what I do know has occurred with PLAs is that basically the material hasn't been around long enough to do any long-term studies on it and its effects on the health. It has been around long enough to do some short-term studies. And the results of those short-term studies found very little. And it didn't warrant doing a long-term study. So consequently, no company has provided the funding to do long-term studies on PLA. So there's actually a chance that it could be asbestos, essentially. It could be the next asbestos it's going to hit us. You don't know.
Well, on that note, I do hope it's not, because if we did a short-term study these days on asbestos, I'm sure they'd very quickly discover it was worth a long-term study as well. But the thing that I noticed that we haven't touched on is how we assemble it. And with the PLA, I was using a plastic weld yesterday, and that must have VOC. That must be pretty bad for you.
Yeah. I mean, if it can melt styrene, it's going to be harmful.
Yeah. So obviously, I mean, and we're not here to talk about safety necessarily, but you should be safe when you're using these things. So I just want to quickly mention with the welding, what are the options? Because Mark talked about using epoxy. Obviously, Jack's put his epoxy over the top, but obviously somehow welded it together first. I'm using the plastic weld that I could get in this country, which is very similar, I think, to what Ray recommended that you can get in the US and in Australia. Are these the best things to use? Because the weld literally bonds the plastic together, so it becomes one piece.
Yes.
The epoxy is adhering it together and gluing it. What is the best? Presumably, weld is much better than epoxy.
Well, I look at it like this. If you need to do, let's say, a job and it needs to hold, let's say, in the instance of guitar strings, it needs to hold about 90 pounds of tension across it. You've got a material that joins the two surfaces together, like the plastic weld, which is obviously going to do the job if it makes them together. And you've got another material that doesn't join them, doesn't melt them together, but it glues them together and is capable of withholding 180 pounds. Which one's better? Doesn't really matter at that point, Yeah. So I use the plastic weld because it's fast. It works really quick. Sometimes a little bit too quick for me, especially if a part doesn't want to go down and sink into place. By the time I turn around to grab the mallet and give it a little bit of persuasion, it's not moving ever. It's locked in place. However, when you're using the epoxy, you've got time. You've got time for it to cure. Like, most of the epoxies are about 20 minutes, half hour before it's workable, I think.
Mm.
Yeah, Daniel, it all had to do with being kind of familiar with epoxy for me. Like, I understood epoxy. I knew how it worked. I knew what the outcome was. And so that's why I chose it. No other reason.
Epoxy shaming you. I wasn't trying to. But yeah, of course. Using things that are familiar makes sense. And this was all new to me. A lot
of my early guitars were two-part epoxy glued together. The biggest reason I went to the solvent adhesive was cost for me. Didn't work out for you, Daniel. Sorry, man.
Just so you know, the stuff Ray recommends to import it to the UK, it was about £50 for a small bottle. I ended up getting a bigger bottle of something I could get in this country for over half that, under half the price. So
I wonder with the pipe welding being Q work, Daniel, because that's a plastic welding tool.
So if I was still bothering to make more YouTube videos, I have lined up in my workshop all of these things ready to go. I've got the what do they call it? The Airfix models use a particular cement adhesive. I've got that. I've got the pipe welding PVC adhesive. I've got the plastic weld, and I've got epoxy. But I've also noticed lots of people use CA glue. So that's also a thing. CA glue to me doesn't necessarily seem like it will work in the same way, but I guess it's also very strong. Like Ray's saying, the epoxy can hold more strength than the strings can put on it. If the CA glue is doing the same.
Yeah, so I do wonder about the CA glue, because I know that like a lot of the parts, especially with mine designs where the parts interlock with each other, I sometimes often think that the glue is just a cursory thing, just to make myself feel better, because Glyn, you would have found out they're not moving.
No.
They won't go anywhere. So for some of those designs, you know what? I'm sure CA glue would actually be just fine.
You know what? Looking back, what I could have done is done that push fit and give them a tap and got them all right, and then seep some CA glue into it, just let it seep in, and jobs are good. And that would have probably been, looking back, I'd have probably got a nicer joints and lots more time on it. Yeah.
I'm going to go back to my excuse for why I printed it in a crap setting, was so I could experiment on all of this and learn all this. But when you've got the top and bottom half, they need the weld, or they need something to attach them to. The other reason I did it cheaply is I want to experiment with painting on the surface of them. So I wanted one I could just quickly print off, so it's the material and it's the size, so I can practice different types of spray that I'm going to put on, different types of filler, just to see what the difference is, and as ways of hiding the joins. Have any of you done any of that? Obviously, Jack's carbon fibered his. Have any of you painted onto the PLA yet?
Oh no, I have actually. No, I did a logo for something. Yeah. So I just use I just think brand names are going to be no good with the international aspect of this, but no, like a filler, primer filler sort of spray, which actually filled the pixelations really, really well. I'm just sprayed on top of that, but it was a logo, so it wasn't going to ever be touched or moved, or it's not like a guitar body where you're going to have rubbing against it, but that worked really well. But don't know, experiment.
Well, my question is going to be for you once you start this, Daniel, and I'm sure the other guys here will know this. You will not have a fun time sanding PLA. I'm sorry.
Yeah, no, that's why I'm experimenting this, but that's why I'm looking into the idea of putting some sort of epoxy filler on it, or a high build spray you then sand, like a sanding sealer that you might put on wood.
So high build works really well.
Yeah, and some high builds are designed for bumpers, like on cars. So they're designed to go onto something that is a plastic. They're designed to have some flex. Maybe there is a way to use those.
Yeah, so what tends to occur with PLA, is as you're sanding it, you remember that I mentioned that it has a low melt point? Yeah, that's what happens when you sand it.
Cabinet scraper. A cabinet scraper is a bit better.
Good tip.
Oh, I haven't tried that.
Yeah, because you're not heating it up with a scraper, and it's still not super great, but it's better than mucking about with sanding.
No, but if you can take off the majority of it doing that, and then just come along afterwards, because I will sometimes get to a point where I'll drop to a 400 grit wet and dry. I find I get a bit more out of that, purely and simply because the water's keeping it cool.
I can probably speak to this because I professionally sprayed cars for a few years, and I still have all my spraying equipment here. A plastic primer certainly as your base coat, and there's lots of cheap, inexpensive ones you get in car shops for that. UPAL do ones that are quite flexible as well. But then what I would go for is a two-part high build epoxy primer, because you'll be able to build up at least 1 millimeter or 2 of that on top of what you've got already. And that'll seal in any imperfections. And then you can take that back with 800 wet and dry, and you'll have the glassest flat finish that will take a base coat very easily. But a two-part primer is probably the winning recipe here, because of how high you can build it. Aerosol high build primers, they call them high build primers, but they're not really. You'll get maybe 0.5 mil to 1 mil out of it if you're building up layer upon layer upon layer. But a two-part one works really well.
Oh, great tip. Just before I get on, because we're running out of time, and I want to get onto the question that Harmonicast put in right at the beginning, and we haven't had a chance to yet. I just want to very quickly share on the screen for people watching, and people that are listening can go and look at Ray's Instagram. I'm talking about painting it as a way of finishing. Obviously, like Glyn held up his jigsaw one, you pick the colours. The jigsaw is integral to the colour scheme and the design scheme. Mark's the way you printed yours, it doesn't necessarily need the paint, all the joins are hidden. But Ray sometimes does finishes like this, where you've printed parts like a top, like where you might put a flame top on a guitar. You print parts on a top that individually come together to make a design, and that conceals any joins from the jigsaw underneath. So that's another alternative. Hey, look, so the question I wanted to get onto that Harmonicaster mentioned, and actually he mentioned somewhere else kind of connected to it when we were talking about Glyn, when you're talking about printing bobbins. He's filament printed pickup bobbins and embedded neodymium magnets right into the bobbin. And his question earlier was, have any of us considered embedding metal hardware like nuts or magnets into the print?
No. Oh, yes, but no.
Oh, yes, you have, but no. Because I know Jack, for example, is thrown off topic slightly, makes a lot of parts for the guitars himself through his CNC and milling. So I wondered if you would consider how they might integrate into the design process or the making process.
Yeah, so for this one here, going back to this one, all the hardware is all mounted on brass inserts. So when I did the printing, I allowed a certain amount for putting in the brass inserts afterwards. So any of the bolts are machine screws and threaded inserts. And the way I put them in, I made a hole slightly undersized, and then heated up a soldering iron and touched that onto the brass insert and just melted it in. I found that was the best way of fitting them. So instead of using wood screws or anything like that, because you want to take things in and out, and having a threaded insert was, I use it on my wooden guitars anyway, so it was a bit of a no-brainer.
You're on mute, Dan.
Can't hear me, yeah, so I keep muting. Yeah, if you're using them anyway, it makes sense to put it across. So I've got a question about that then, because on this one here, the one I did last night from Ray's print, what I've done is for the pick guard, Ray had made the countersunk recesses in the pick guard, but then I just drilled a little hole into the PLA and screwed them on. That seems to me fine to hold that. But where the bridge is, where it's taking weight, Ray had designed the screw holes for the bridge. I presume, Ray, you've done what Jack mentioned earlier on his, where you've reinforced behind that or made a more dense or solid print for that. Is that correct?
Yeah, so typically that so each screw hole will have its own wall of 2.4 millimeters. The other thing that I'll do is I will take that hole, regardless, like it only needs to be 25 millimeters long. I will take it right through the body of the guitar, and that way the front of, I guess, the top of the hole is connected to the back of the guitar. Now, I I get a lot of people asking me about why don't I use brass inserts to put my bridge on or to put the neck on, and that is a really good question, and there is a reason that I don't. If I can find one, because I've got a bunch. So first off, I've got no issues with people using like the threaded inserts for things like pick guards and stuff like that. Can't find one at the moment, but the reason that I do that is, or I don't do that, first off, as far as I'm concerned, I'm probably going to get shot here for this. Once you put a guitar together, you've made a custom guitar the way you want it, with the pickups and the hardware that you want. There is very little reason for those parts to come back off, unless you need to repair or something like that. But I don't really want to build in something to make all of that easier when I want to keep my hardware part count down. So that's why things like the pickguard screws, I don't use them. But if people wanted to, go for it. The other issue with those is they can be a little bit hard to get level, but you know what? There's nothing to say that you can't just countersink them a mill underneath. That's my biggest reasoning for wanting to do it, or not wanting to do it on like accessory parts. I absolutely will not do it on anything that that is load bearing. People think I'm crazy because it's just like, yeah, but you're going to put a machine thread screw into it versus a wooden screw, like a wood screw. I'm like, well, let's look at surface contact area. Let's look at, like, if I use a threaded insert, it's what are they? They're like between 5 to 6 millimeters long. Sometimes you can get them longer. Cool, that's great. So when I put that screw through the bridge into that threaded insert, I'm getting 5 mil bite on the screw, and that's bite got 5 mil depth of bite into the body of the guitar. Whereas if I take a bridge screw, it's 25 millimeters long. It's going straight through the body of the guitar, and it's biting into those walls. That's a lot more surface area. That's a lot more strength. It's a lot more contact area to transfer, any vibrations and tone through that could potentially be there. Whether it is or it isn't is not up for discussion.
Hey Ray, on that note, I remember when I was building my guitar, I took all your advice for screw holes and it came out perfect. So I definitely recommend following Ray's advice. But my first question to you when I was doing this was, I remember wanting to do a set neck. Like, I remember wanting to glue my neck in to the neck pocket, and I was asking you, should I go this method or should I use screws? And I don't remember where our conversation landed, but can you maybe talk about a little bit about maybe if one of us wanted to do a set neck instead of screws, is that possible, or would the glue and the tension just shear off the neck?
Good question. So it's kind of like when you glue something onto a painted surface, you're gluing onto the paint, essentially. And the same thing can be occurring with a 3D printed guitar. You are gluing onto the first layer. Hopefully, if you're using a solvent, you're gluing onto the few layers underneath. What I've come across, or I guess I should say what I haven't come across, is an adhesive that is solvent to polymers, but also holds wood. So like a wooden neck. I haven't come across anything that will do that reliably. If anybody knows of anything, please let me know, because I'm all for it. However, if you wanted to 3D print a neck and make it a set neck or a string through, I think at that point you can definitely do something. But I've always just personally, when using adhesives or trying to find adhesives, anything where I'm trying to bond two vastly different materials together, there's always something that has to give. One side of it is not as strong as the other, or so on and so forth.
Sorry, Ray. Can I just interrupt there, because you're not gluing wood to plastic. You're gluing polyurethane to plastic. It's usually polyurethane on the neck. So you know what I mean? It's not wood. It's whatever finishes on it. So isn't that would that? I haven't tried it. I've got some here, and I could do. But that glue, would that not help dissolve two-pack as well?
Hold on. But when you're doing a set neck, don't you normally glue the neck in before you put the finish on?
Yeah, you would be. Oh, there you go. Maybe you don't have to. Maybe you do it the other way. Maybe you put a finish on it first.
Oh, yeah. Well, we need someone to do all these experiments, Ray.
Now, if epoxy, I don't know if you've tried, the slow cure epoxy. So let's say Araldite, which I think is international. If you take Araldite standard, not repeat, but standard, mix it up, warm it with a heat gun, like a low setting, like a hairdryer setting. That just goes like water, and that soaks into any grain. So I mean, that's great on wood. Like, if you do it with the repeat stuff, it just goes off like nothing else and goes horrible. And but I wonder if
It wasn't me. I didn't.
LA, yeah, it's gone mad, isn't it? I wonder if there's a way of bonding that into because the PLA is not that smooth surface.
No, well, I see, and that's a really good point there, because I mean, like, I know when I'm often using like two parts, and then I'm join two smooth surfaces together. The first thing I do is I grab a knife and I'll score the surfaces so the glue's got basically something to bite into. So that's actually a pretty good train of thought there, and I'm gonna have to sleep on that one, because I'd love to know. I'd love to be able to do it. And this is actually one of the beauties of 3D printing guitars that I absolutely love. I guess you could say that, yeah, I do have a lot of answers about 3D printing guitars. I've printed so many of them because I fell into a rabbit hole and I've tried so many different things. But I still get asked things, it's just like, well, how long is it going to last? I don't know. I have no idea how long any one of these guitars will last.
I've got a great thing to ask about that then, because it occurred to me last night when I was printing your guitars that there's a definite difference between one of your guitars and buying a guitar. And that is because people are printing it themselves and assembling it themselves, and you make them so they're simple to do, right? You give all the instructions for that, and that's potentially why you don't put all threaded inserts in as well, because it's just simple to do. It occurred to me once I put this together, I could easily just print another body and in an hour swap the whole guitar to a different guitar, like not different guitar, color guitar. So the fact that it's made to last seems almost irrelevant, because you just print another one or print a different one. Or if you get bored with it a bit, change it.
I was waiting for this one.
Are we in the era of disposable guitars now?
Well, yeah, because
we have been for 75 years, haven't we? Wasn't the Fender supposed you to throw a Fender neck away and replace it? I mean, you could ask exactly the same question about a Telecaster. How long is it going to last? Well, I know, I'm cocksure that a Stradivarius can last 300 years, and they're a flimsy little box, So, don't know.
Maybe a 60-year-old Tasmaniak 3D print, original 3D print that has walked a bit, is going to be like a relic, a 3D printed relic with extra value to the future. Who knows?
But the sheer fact of the matter is that the polymers and the various materials that are in the polymers that bind everything together, they break down over time. You know, it just like wood, you know, rots when it's, you know, not sealed. Yeah, the same thing is going to happen to these guitars eventually. So yeah, I do get a lot of questions or people telling me that it's no point doing it because it's not durable. It's just like, well, if I want it durable, I'll go do something else. You know, but at the end of the day, you know, they are tough, but I don't know how they're going to stand the test of time. So when, you know, a lot of people will ask other questions like, you know, can you do a set neck? I don't know, man. I know my thoughts on it. I know what I've tried to do. But the thing is this whole idea of using 3D printing to make a guitar, it's new. It's new. Like we're talking about, you know, us being experts. I don't think we are. You know, I certainly don't think that I'm an expert in 3D printing guitars. I might call myself a pioneer, but that doesn't make me an expert.
I'm going to change the description now. Pioneer of electric guitars.
Just going back to the set neck thing, because this is churning around in my head now. There's that woodworking principle that the glue's irrelevant. It's the tightness of the joint that's the important thing, and the glue just holds the joint there. Yeah. So obviously, if you most set necks, the joint, like if you look at a Les Paul, the joint doesn't have much strength because it's just a silly tenon. But you can make it strong. You can make it strong by putting a cup. You know, if a tenon's like that, and you put 2 pins in, then suddenly you've got it, so it won't slide out. Or, you know, there's ways of making a joint a strong joint, and the glue is just, you know, just holding it in place rather than the glue being everything. So a rethink of how that joint works. You know, or you know, like a dovetail, like an angled dovetail on a Martin, or proper Martin old one when they used to make them, like they knew what they were doing. Those sort of dovetails can be very, very tight. So anyway, I have no solution. I'm just suggesting a method of thinking.
So it's something that's, you know, I've put a lot of thought into. And some of you may remember that I did actually make a Les Paul that looked like it had a set neck. However, it did not. It was basically, there was a clamshell that went over the back of it to hide the screw holes. And instead of coming in from underneath or the back of the body, the screws actually came in from the side. And when you're trying to figure out how the hell did he do that, you know, because the Les Paul's that wide, I print in parts. So, you know.
But I think that fits into what Glyn's saying and what I was trying to allude to before, which is you're making your guitars simple for people, and that means they're buying in a neck. But Glyn's sort of implying, and I think it's like if Jack's making his as a bespoke builder, you can make the neck a different shape. The join, the heel of the neck can be that different shape to make it bond better with the join simply by the pressure of it all fitting together.
Well,
Jack,
the other thing you can do, mate, is you know, the issue that I was talking about was we're joining 2 different materials. You could also just make the neck from the same material. So there is a 3D printed neck. It's, you know, still got a little bit of work to come along, but that thing's bloody strong. You know, it's not going anywhere. I did make some trial and errors. So I do have this one, which was the very first one I made, and it's probably not so good. But when you take this one and consider that it's got no fretboard, it's got no truss rod, it is just purely material at this point, and the best you can do is that sort of flex. I'm getting close. I'm getting close.
I mean, if the purpose, I mean, I see 2 purposes of a glue-in neck. One is the tightness of that connection, that coupling between the neck and the body, and the other one is to attempt to remove the heel so you can play up the dusty end easier. Now, surely it doesn't matter if it's glued and bolted and you leave the bolts in. Then as long as if you were going for both of those things, as long as you could sort of remove the heel, so you could make a Les Paul, you could bolt it on and glue it and leave the bolts in. I don't know.
Yeah.
What are your thoughts? Mark? Because you started on the gluing subject.
Yeah, so I had designed my heel to be as low profile as possible for my neck. So there was no heel. And I didn't put my screw holes in until after I had a conversation with Ray, because my first question was, can we even do a set neck? Because the only fear I had was that it was just going to shear off that first layer, like Ray mentioned. But then I never thought about designing the heel, the heel of the neck with the pocket in some kind of like woodworking way, like a dovetail or like a tenon. So that never occurred to me, but maybe you're right. Maybe if the joint itself is designed properly, then it doesn't matter. You can just glue it in and it should work, but I don't know. But that's the direction I'd like to go.
And the bolts don't have to come in from the back either, which is another thought, is the bolts can come in through the fingerboard. Or under a fingerboard, or there can be, inlays to hide them or something. It can be maybe worked another way. I don't know.
Yeah. So the instance of my Les Paul, they actually came in directly through the side.
Yeah.
I love the idea that we've got to a point at the end of our conversation where we're thinking about using non-traditional materials, but now thinking about assembling it in a non-traditional way. Because I guess my thought process at the beginning of this, with a neck that's not 3D printed, is you have to have a very traditional connection for it. But as we're evolving the design and the materials, why not evolve the way the neck attaches to be more conducive to the process, the method?
Well, that's it exactly. It was actually something that Glyn said to me on our second live stream, and Glyn, I think to you it was just an off-the-cuff sort of statement or question, but it was actually something that stuck in my head and has made me rethink a lot of things. And you've said to me, it was just like, if you've got this technology to create things in this manner, why are you still building in traditional methods? Why are you still using traditional shapes and bodies and things like that?
Because it's a two-dimensional thought process making. It's a plank. You're shaping a plank.
Yeah.
Well, that's it. And I was sort of after the, at the time I just sort of like, well, because they're guitars and they need to look like this. But then I thought about it afterwards, and I'm like, well, exactly. Why am I still doing this? So I've started to work on that. And not just in the actual design, but also the way they come together and things like that. I do know that, I'll never be, how can I say, they will never be a popular design of mine. Purely and simply where I'm asking people to change their way of thinking way too much. And I know myself as a guitar player, I don't like to change my thoughts about guitars too much. However, not long after, you asked that question, I started to think about it. And then, Mark, you came along with your V, and that V is exactly that. You cannot make that guitar using traditional methods. Or if you did, you'd be crazy because it would be so much work involved. So this talk of, how would we join the neck on or a set neck, to me, is just an extension of that discussion. We have this technology, we can do things, or everything we do with a guitar, and even, a 3D printed guitar, we do because it's done, that's the way it's been done for years and years and years, centuries even. using wood. But there's a lot that can be done with a 3D printer and just additive manufacturing in general. And yeah, I'm looking forward to seeing what can be done and where it can go. I think it'll be really cool.
What a great...
Sorry.
I was going to say, what a great note to end on, because you've been talking for so long, but Glyn's got a better note to end on.
No. I'm just saying you really got to admire Ken Parker, because Ken Parker was thinking in the 90s in different dimensions with different shapes, and love them or hate them, those guitars are so comfy and they work so well. I think nothing's new in the world. I think looking at Ken Parker's designs, very worthwhile.
Yeah. Well, I think a lot of it for me, I guess I'll ask you guys straight out. Why do you build a guitar out of wood? Why?
Because
is it the best material to build a guitar out of?
Yeah.
Or are you doing it because that's what's been done for bloody centuries? And, when they first started building stringed instruments, how many centuries ago, why did they use wood? Because bronze was too fucking heavy.
Yeah, I'd probably burn my house down if I tried to smelt aluminium. So I'll stick with wood.
But that's the simple thing is stringed instruments, are still being made out of wood because that's how they were done centuries ago. Centuries ago, they were made out of wood because that was the best material that was available at the time. Is that the case today?
If we think broader than guitars, though, and I'm conscious of time because we chatted a long time. But if we think broader than guitars, there are instruments commercially being manufactured at scale out of plastics, wind instruments for students who are learning. Some things do lend themselves better to that type of production. But I think one of the reasons for wood is just that there's a mystique and a nostalgia, and certainly some truth to the fact that choosing the different woods allows you to express your personality a little bit more, and that's why we choose to buy different guitars. Ultimately, it's down to that. It's people's personalities are driving the choices behind the guitars they make and the guitars they buy.
And there's plies as well. You could if you make plywood properly. I've got a skateboard guitar, and it's the most resonant instrument I've ever played. It'll sustain forever. Maple ply that's been put together with that much compression, designed to have teenagers jump on it for hours on end. It's amazing stuff, and that can be any shape. Or like an ES335 that I mentioned earlier, that's a plywood guitar. And ply can be molded and shaped, and it's actually, it's offcuts on the whole anyway.
Most entry-level double basses are made, and cellos are made out of plywood.
Yeah. Well, a lot of old Yamahas were ply, and they were great. Old Yamaha acoustic guitars. Yeah. As long as not just any old ply, it has to be put together properly with that proper compression, good glues and stuff.
Do we want to talk about drum shells?
Yeah, there you go. Yeah.
I will say drums and drummers are not musical.
Ooh.
I know, important words.
For some reason, a lot of the early guests we had on the Guitar Builders Collective podcast were all people that built guitars but started off as drummers. I remember that very distinctly. One more thing about wood. I know that a lot of the people we've had on the chat before, wood is the thing for them because they love the patterns, they love the grains, they love working with the wood, the whole process of it. So for people that are bespoke individual builders, a lot of it is the joy of the making, which is obviously a very different type of joy when you're doing a 3D print guitar. So what I definitely want to say is if anyone's been enjoying this, 100%, we're going to do an episode where we talk about the whole design using CAD at some point. And the thing we haven't touched on at all today, which all of you said in the beginning, especially Jack and Owen were saying, and Glyn was saying, you print a lot of the tools and templates and things. So I think we should have an episode about that. So maybe not in depth about how you print and all of that, but what you print and why. Jack was just holding some up, and look, Owen's holding some up. Glyn can't hold it up, but I hear his camera's on a.
Look, everybody's doing show and tell.
Some at the back there.
Oh,
They're
look,
everywhere.
his own radius block.
Hey.
There.
I asked my daughter the other day. My daughter was in the workshop and she said, "Dad, can I do something?" And I said, "Yeah, design me a little box on Tinkercad. I just need a little box to put some stuff in over here." So she made a little box and she put it through Cura. And she put it on the printer and she printed it out. And it's really cool. I got this little box on there now, and it holds some other little tools. And it says on the side, "Dad is a poo."
Amazing.
Okay, I did just want to touch on this. It won't take a minute. So one of the things that I love about 3D printing, like parts for guitars, is something that we can probably all relate to, is pick guards. You know, even when you get down to, you know, I create they're almost like a ply. So when I figured out how to do like a ply look, a 3-ply or a 5-ply look, I was like, well, what else can I do with it? You know, I can put logos on there, like, you know, our, you know, Tasmaniak Guitars, things like that. I thought that was pretty cool. I figured out that I can put pictures on them.
Yeah, 100%.
So 3D printed pick guards. And come on, Hello Kitty, man.
Yeah, no, I've been thinking about this for ages because I was resin casting. I've been resin casting, as in traditional making molds and casting things to go on guitars for a while now. But the 3D printing, that's just brilliant for that. Whoa, that's a whole other thing to talk about. We've already talked for 2 hours. So what I want to do, if everyone's up for this, is get you all back to talk about the jigs and things we have around the workshop, and get Arran from Adair Guitars, who's also a regular on here, on, because he has just, I think he's got a video coming out about it quite soon. He's just printed parts for a guitar that he's made, which is his like test guitar, to try out pickups on, to try out positioning for controls on the guitar and how they work in conjunction with the pickups. And it's all interchangeable parts he's made. It looks so cool. But I won't ruin the surprise. There's a really cool kind of theme to it that you'll see in his video.
I'm looking forward to it.
Yeah. I don't think we'll go around and ask everyone about their favourite jigs. There's just not enough time. But thank you all. If you've been listening and you want to hear more about 3D printing, please let me know what we can focus on next time, because I think this is definitely something worth doing, particularly partly because of Ray. Everyone now that I seem to talk to is considering getting a 3D printer or has got someone else to 3D print things. It seems to be something quite popular. We're having a break now until January, but in January we've got a few new guests lined up. I'm going to be lining them all up on the schedule soon, so you'll be able to see there's a playlist in the video and podcast description of all the episodes we've had so far, but it also includes the forthcoming episodes. I can schedule that for 6 weeks in advance. You'll see the next 6 weeks of them. But yeah, we'll all be back definitely to talk about jigs, to talk about bits, and another one maybe to talk about CAD. Thank you all so much. And just a quick thanks as well to the members of the channel who have helped support all the streaming and the production of this all. It's Every Guitar Has a Story, Big Unit Guitars, Daniel Marquez, Dinsey, Gabriella Retti, Entropia Guitars, Electric Lady Guitars, Adair Guitars, BB Guitars, Simon Chapman, Mr. Glyn's Pickups, Dave Dickinson, Tasmaniak Guitars. Brilliant. There's links as well to all of us 6 below, all our social medias and places you can get hold of various files. Mark has got some of his 3D printing files you can get for his guitars and other things. Ray's got loads. Jack also sells things. Jack, you sell your 3D printed things, but you also sell the files.
No, I've never been asked. But yeah, everything's for sale, you know.
I highly recommend you check out Jack's custom tremolo arms. Very cool. All right. Thank you, everyone. So until next time, Merry Christmas, a Happy New Year. And to Scott that's not here, who may not even listen to this for the next couple of days, I hope your wedding goes very well.
Ah, cool.
See you all soon.
Happy Christmas,
Bye.
guys. Take care.
See ya.
The Guitar Builders Collective is a group of like-minded people from all around the world at different stages of their guitar building journey. You can join us over on our forum to seek advice or share tips on guitar building processes, materials and tools, or just to share your builds. On YouTube, we have a regular podcast of guitar building chat where you can join the live stream or watch back on past episodes. Our Instagram page shares posts of members' builds and links you direct to their accounts. And for those of you on Facebook, we've got a private group that you can join, share and chat along with. The Guitar Builders Collective is a welcome and open space for all, so do pop by and say hi.